All right, welcome everybody to Lakehouse Demystified. My name is Caleb Benningfield. I'm here from Amperity. Amperity, if you've never heard of us, we make a customer data cloud. So this is also consider this my bias note for everything I'm about to say, but we make a platform that's designed to take raw data, turn it into unified data, and then give marketing automation tooling to an organization, sort of bridge that gap between data management and marketing. But key element today is we're going to be talking about the Lakehouse architecture here. So, first things first, we're going to talk a little bit about what Lakehouse means, a bit of a buzzword lately, and I think it's good to kind of show what the key innovation is that's really kind of opening up a lot of doors in terms of much more flexible architectures. And then we'll talk a very high level about how web applications work in a similar way so that we can then connect those together and talk about how we make a composable architecture and what the vision is of that, and then also what the reality is that you'll have to sort of live with when you're looking at your options and kind of building out your architecture plans. And then we'll show how show a little bit about how I'm doing, our team at Amperity has been taking those concepts and trying to bring them to life to sort of realize that vision. So, Lakehouse core concepts, deciphering buzzwords. So, let's look at the basic evolution of storage. I think in the beginning, we all had databases, sort of like your MySQLs, Postgres, even Oracle on-prem. You would set up your own actual, computer and install that, and the resources that were on that box would directly reflect what you could do there. So if you wanted to be able to do machine learning sometimes, and you needed a lot of compute for that, then you would create a box that had a ton of overhead. But then if most of the time you just need it for small querying, you would be paying for that upper level overhead at all times. So it's always on, and you're paying for it 24/7, which is, which as things scale becomes problematic. So that brought us, as the cloud kind of came along, to the cloud data warehouse. Now, the good news about that is that you get to use cloud storage, which last I checked, S3 is like $23 a terabyte. It's basically negligibly cheap. And then the key here is that it gives you the ability to have different compute that you use for different jobs. So in that scenario earlier, you have your big machine learning job. So you have your big one in the middle here, but then day to day, your analysts are just running SQL queries. They don't need that, and so they can use smaller warehouses. And when the big machine learning job isn't on, you're not paying for it. So it gives you a lot of flexibility in terms of what you're basically paying for what you use, a lot of control over your costs, and it helps organizations scale, and was a really big kind of stair step. And that sort of began with like your Redshift era, and now we've seen this shift into lakehouses. And I think that term gets sort of used interchangeably in a bunch of different ways here, but the key here is if cloud data warehouses made it so that you had flexible, different forms of options for compute, the data lakehouse gives you that as well, but also gives you the ability to have flexible storage. So now, rather than having everything in a single spot, you can now have, one set that's for dev, one that's for prod, or one that's in Amazon, and nope, you're migrating some things to GCP, you could have a separate storage layer in GCP and use use that same modular compute layer basically interchangeably to pair which compute is going to which storage in a really flexible way. Now this, opens up a ton of flexibility, and so I want to kind of dive into the general architecture of a lakehouse and then how that gets applied in the market here. So a lakehouse has some basic concepts. This is very generalized, but you have cloud storage underpinning all of it, and that's sort of your AWS S3, Azure Blob, and Google Cloud Storage type of stuff. Again, dirt cheap, lots and lots of space. Then you have your compute warehouses, which will have a lot of different names. This is where you get into marketing land with a lot of things, but you'll have general service compute, you'll have compute warehouses that are specialized for SQL workloads and analytics, and you'll have things like serverless compute that make it not your problem to have to think about the compute. And then the big thing here is that they've added this catalog layer concept. So the catalog layer basically gives you this ability to do unified governance. The catalog is where you control which APIs or API keys or which users have access to which data. So this is kind of the core of the vision of the lakehouse, is that you can use this unified catalog and have some data stored in account A, some data stored maybe in account B, some data stored on a partner's account, but you can use a unified governance layer to control who gets access to what. So if we take those core concepts, this is where you get into weird marketing terminology. I kind of state it in this general way because when you look at each of them, you get different names. And this is not comprehensive, but this is meant to kind of explain the point here. So in Databricks, you have your classic compute, you have your SQL optimized warehouses, and then you have serverless, which is, again, kind of looks at the thing you're doing at the time and optimizes it from a large pool of compute. And then their catalog, they call Unity Catalog, and then the storage they run on what they call Delta Lake. Now the same thing on Snowflake, they have their virtual warehouses, but then they have Snowpark for more advanced data science. Their catalog layer they call Horizon, and then their storage is databases, and under that there's like external tables, there's iceberg tables, there's native tables. And then Google is a little closer to the terminology that they use for their actual their cloud bit, their cloud offering, and you just get slots of compute for different sizes for different things. And they call it, I've never actually heard anybody use this, but I was trying to make sure I use the most current terminology, the Dataplex Universal Catalog. And then they just call them data sets down there. And that data set could be stored pretty much anywhere. And so you kind of I think the hard part is that means that you have to sort of understand the concepts of how a lakehouse works, and then your chosen lakehouse, what their terms are in order to even understand what that means under the hood. But you could very realistically use these somewhat interoperably here. You can register Snowflake tables in Databricks and so on and be able to query directly across them because, again, all the storage, no matter what they name it, is effectively files and cloud storage. Now, I'm going to talk a little bit about web apps. This is not a software development course, so don't, it's very zoomed out with the point of talking about it in the frame of the lakehouse. But basically, every SaaS app, including Amperity and pretty much anything else you've used, you build an application, you have your cloud account, you have your storage, which is where it's going to store what that application needs. So it's your data, your accounts, the configuration of your account, that kind of thing. Then you have your compute, which for each feature that you have in that application will probably use a different compute profile. And then you have your code. And so this is going to be the actual application, this is the user interface, it's the algorithms that you're using, it's the feature code, right? So think of it as like if it's a marketing cloud, if you have a segment, you're building a segment engine, your code is going to be your layer that shows you, the ability to build your audience, and when you click run, it's going to grab some compute, probably running some SQL, and it's going to access storage, and it's going to return that up to the code, and then you'll see your result. So, like a very common pattern that I think most of you will be familiar with, is if you have your data warehouse today, each of the applications you use have this general pattern in it. So you might have a marketing cloud, and it has its own storage, its own compute, its own code. You might have a paid media marketing solution, same difference. You might have a real-time event thing that's like very focused around moving events around and has its own storage, its own compute, etc. And then what you do is you write the dreaded ETL, which, extract, transform, load. You're extracting data from this, your storage layer, and transforming it into something that's compatible with these storage layers, and then each of these applications will ingest that data either through big bulk file uploads or through API endpoints, and the ETL's job is to basically translate that data from A to B. Now this is pretty normal, to be honest, but it's becoming, as things grow, much more complicated. Right now I've given you this very simple example of 3 things. Doesn't sound that bad. But in the modern world where we're constantly adding new endpoints, now we have all these AI agents that are going to need it. Now we have all these different marketing channels. We have, as social media evolves. Basically it means that it's really drowning all of our tech teams because they have to write, it's not one ETL, it's probably tens of ETLs up to hundreds of ETLs. So a lot of Amperity customers are big enterprise companies that have genuinely hundreds of tables, and so it could be hundreds of ETLs for you to have to manage. It also means you're creating copies in all these third-party accounts, right? And especially as security regulations get tighter, that's becoming more and more of a pain too. If we want to be GDPR compliant, then somebody says, hey, where do I live in your data? Then they probably live here, but a copy of it lives here and here and here. It also creates lag. So like you update data here, but it won't be until the ETL runs that it gets reflected in each of these systems. So there's a timing element that you're having to deal with. So the Lakehouse architecture is the solution to this problem, or at least a really great opportunity to make this better. So let's talk a little bit about composable architecture and the sort of vision behind it here. So you have your Lakehouse, and it has its storage. So now you want to use applications, like, and for this example, we'll say a SAS ETL tool to pull data from all your source systems and populate your data lakehouse. Then you need another platform, maybe a DBT, or you're using an MDM or something, or you're just writing your own scripts, but you have something that's modeling that data, and then you take that data, maybe you're using a Tableau, and you point it at that data for analytics, and then you need to pump that data and give it access to your marketing team so they can automate and send that data out. So historically, if these all used to be their own hosted things in a SaaS, their own SaaS account, their own AWS account out there, ideally, what we can start to build towards is this modular sort of Lego approach, where each of these bring their code to the table, but they don't necessarily have to bring the infrastructure to the table. They can ship that compute down and say, oh great, I want to pump this data in, so I'm going to run this job using your compute in your account. And then you do the data modeling, same difference, and analytics, and reverse ETL. And in all of these, it means that all of these applications you're using, you are basically plugging into your data warehouse, but at all times, it means your storage and your computer happening in the same place. So, super useful for a lot of reasons. That whole data copy element, well, if your activation or analytics tools are using the same data sets that you're creating with your data modeling tools, you don't have to deal with that sync problem. You update it in your data set, and then instantaneously your analytics are able to see that. There's no like, oh, tomorrow it'll be up to date type of thing that you deal with today. And so it has a lot of big upsides here. So I think especially here, you have with GDPR and kind of increased pressure to deal with where your data lives, it gives you an ability to have that unified governance layer and control over where your data is finally stored. And it also gives you that modular architecture. As I said, like it becomes harder and harder for teams to keep up with the constantly changing landscape. And so you want to be able to take one, like you want to say, oh, Salesforce Marketing Cloud's not doing it for me. I'll unplug that one, I'll put in Braze, or vice versa. And kind of allows you to evolve more quickly because you're only having to change what code is accessing which data versus completely write a bunch of new ETLs and rebuild all your automations for the next thing you're switching to. And then also it makes it easier to scale as the company grows. If one set of the compute that you've assigned here is not, you had 10 million customers, it was working fine, now you have 20 million customers, well now it's getting slow, well you can directly affect the compute assigned to that application, so it gives you this ability to sort of scale as your stuff grows here. And then the other big thing is that applications evolving on your own. So Amperity is a SaaS application. We are, as people add new stuff, we want to build those new connectors so that people adopt and stick with us. We want to add new models. We want to refine the existing stuff, and your teams don't have to do that. And so you're sort of offloading these common tasks. And so it's a huge upside and allows you to sort of build this Lego architecture where you can, if one vendor stops working for you, you can unplug them and plug a new one in. Now, the reality side of it is that there's a reason that companies don't typically build an application that way. It is, Databricks, Snowflake, they're effectively packaging up and reselling parts of the compute from the cloud, right? So it would be cheaper for me to go directly to the cloud most of the time. If I'm building my application from the ground up, I want it to be as cheap as possible. I'm going to run and build it my own way and have as much flexibility as I can because it's like core software development. And so you typically wouldn't build it that way. And so as a result, a lot of your options on the market aren't truly doing a Lakehouse native build. The reality is that you end up with a sort of mix and match, where some of the things are running, actually pushing down compute, especially the stuff that your analytics tool and your DBTs and that kind of stuff is directly running on your Lakehouse. But a lot of your SaaS tools that plug in, that do various marketing activation bits, the reality is there is some element of that will have to be hosted there. So for example, the user interface of any application will not be hosted on your Lakehouse. It'll be hosted by your vendor. And if you click that button to say, I want to build a segment, and it shows how many people are in it and lets you explore your segment, it is visualizing that data on the servers that host the UI, which will not be your servers. And so to some extent, it's actually minimizing copies, it's not actually eliminating it. It does simplify things, but it also creates some level of complexity. Because now in this example here, you also have operations that you have to deal with on each of these. So if you're going to monitor something, then you have to be monitoring the processes that are happening in your Lakehouse, but also processes that happen in each of these different applications. They don't really communicate. So you could change something in your SAS ETL bit, add a new field, but if it affects a data model that's reliant over here when you're building audiences, it could break stuff in this silo that you didn't see on that. down there. So you opened up your ticket in Jira, you added your data, you said good, everything validated, you pushed to production, secretly it accidentally broke something over here, and then you have to know how to go into this other platform over here. So that means the teams that are supporting it, monitoring it, have to know how all these things work in order to support and monitor that. And so the reality is that there are issues to deal with here. It's not as clean, and there's a lot of marketing around it. Zero copy is kind of a marketing term because of what I said about like the UI will never be hosted on your Databricks account or Snowflake account, right? Or at least not at the moment. So you're still providing access like to that third party, and you're relying on legal documents, not actual technical limitations, to keep people from reading your data. And then push-down compute is pretty new to the industry. Like there's definitely some players that have been building from the ground up, but most of them are effectively pushing SQL down, not doing the more complex parts of their application there. So like real-time eventing, for example, is almost never going to be hosted in a lakehouse because that stuff is just, like the infrastructure for it is not great at that. And then also it creates other sort of less obvious, not particularly technical problems, but just quality of life issues, where now if you have Databricks and a SAS ETL tool and a SAS reverse ETL tool, and you have Tableau and you have DBT, that's 5 contracts now, 5 companies that are all going to want to charge you a little bit more each time, that are all trying to grow their own way, and it also 5 different operational areas that you'll have to now maintain. And then the end result is you kind of get this low barrier to entry that tricks you into a higher total cost of ownership over time. Sure, each of those components might be $50K to start, but then the problem is they're all going to want to grow. They're also pushing that compute down, which you're paying for in increased costs on your data warehouse. And then the total cost of ownership of the 5 contracts and the increase in your Databricks compute might be cheaper, or might be actually be more expensive than a unified offering. And not to count the operational burden. The amount of a person to maintain something is, quite a lot overall. A single person is typically as expensive as a SaaS contract is in most cases. So it's not that it's inherently great or bad, but it's good to understand those trade-offs. And the reality is that there's not, from what I've been able to tell, not a SaaS architecture out there where you could go end to end and have every single thing really realize that vision. I think that we're getting there, but it's not. We're not quite there yet, and so it's good to be aware of that. And you will, and kind of focus more on minimizing it, the complexity and the amount of moving parts when you're building out your architecture here. So I want to talk a little bit about how we are trying to apply those concepts at Amperity. So again, this is our sort of salesy slide here, but the kind of key here is that we've built this platform that is meant to span the entire lifespan of your data lifecycle here, right? So you have a bunch of SAS ETL style connectors that can load data into your data warehouse, and you have a semantic tag layer, and you have your identity layer that runs machine learning, and each of these, we built that in a microservices architecture style. So each of those services has its own compute profile, its own way it integrates. What we've done and released about this point almost 2 years ago is what we call Amperity Bridge. So remember when I listed all of those different terms? It's like Databricks calls it Unity Catalog, and Snowflake calls it Horizon Catalog, etc. They have the same thing for their data interactions. Databricks calls it Delta sharing. Snowflake calls it secure data sharing. Google, BigQuery, I believe, calls it it's like the data marketplace or something to that effect. Don't quote me on that. But the point is that they're all a little different, and that what we've done is create a layer here that under the hood, Amperity is a simple architecture where we use cloud storage, and we've integrated this so that you can just plug into whatever that is, and then you can use your own catalog to decide what our company has access to. And so the way that looks, this is not a comprehensive look here, but what we've done is we've been going service by service through our platform and saying, okay, great. We used to have our own storage. First things first, let's make it so that that storage can be in your account. That means none of your data is going to be stored on some random vendor. Don't get me wrong, we're a very nice vendor, but we are some random vendor. And so you can set it up so that it's your own cloud storage. If you ever want to cut us off, then all you have to do is cut off our access via that bridge layer, and you still have your configuration and your UI, but we don't have access to your data anymore. Very useful, very good for InfoSec teams. They like that sort of thing. Hold on. And then now what we're doing is we've been steadily moving through each of these core services and adapting them. And the cool part is that you don't have to, as a user, think too much about what the compute profile is of each. So, a SaaS ETL connector, actually pretty lightweight. All it's doing is hitting some APIs, batching up data, storing it, right? There's a CDC element to that makes it a lot more nuanced, but you don't need a massive amount of compute for that. The identity bit for us is actually up to 45 different machine learning models. Our default configuration for that is 160 different containers that splits off to, and we can ratchet that up and down based on data size, but you don't have to understand that bit. We just provision that based on, thank you, we just provision that based on the compute profile of that given service. And so what we've been doing is steadily moving down here, and then our hope here is that also gives you that unified layer to do changes in. So that original example where it's like you want to make a change to an audience, you want to make a change to the data that's coming in. You want to change what fields you're using, but an audience is using it over here. The way that works if you use a unified layer is that you can say, oh great, I want to create a sandbox, effectively a development environment, that gives me a change of just this config layer. Then I'll change my field, and then that you have out-of-the-box validations that say, hey, that field that you just removed is being used over here, and you can't push that to production until you clear that error. And either change the way that works to use the correct field, or remove that automation. But either way, allows you to sort of just click, create a draft of your entire data architecture, make your changes, and then it will actually handle the lineage of how that data is used in the other parts of the application. And that is like a massive time savings. Like it means that you don't have to build all these migration scripts and unit tests out of the box. You can just say, this knows what data is being synced from here, and kind of knows the data lineage from one end of the pipeline to the other. And it also means that your operations team, you're still going to have somebody who's going to care about your data warehouse. You're going to have all kinds of other things your teams are building. The data sets that are generated from here are going to be used by your analytics team. But when it comes to the data management pipeline of turn your data into something unified and make it available for marketers to do their journeys and segmentation, it means that the validations and monitoring can happen in a single platform, and your own teams will only have to learn the one platform rather than a combination of them, and sort of not have that linkage between the different data steps in the process there. So I think the kind of key here is that you want to be able to grab each of these components and plug them into your data warehouse, and then that will give you kind of the full control over time. And as this evolves, we can adapt more and more things as these Databricks and Snowflakes get more and more advanced. So for example, AI is huge now, and one of the elements that we've been investing in is creating agents that will help you with each of these data management tasks. But you want to be able to run that in a secure way. Well, Databricks investing in more flexible compute and hosted models and that kind of stuff means that all we have to do is make it so that you and your lakehouse can say, oh, I want to use this hosted model, and then our code can just interact with that, and you can kind of add features to this without also adding moving parts and extra problems with InfoSec and security. That was the end of what I wanted to talk about, but I will open it up for questions here. I think there's a mic somewhere. I saw it floating around. 5 minutes left, thank you. But if you want to come talk to me more or us about this, we're at J61 over here. I'm Caleb. We also have a session on those agents that we were talking about tomorrow, so feel free to give that a look. Anybody got any questions? Feel free to raise a hand. Otherwise, I'll let you have 5 minutes back. I don't want to be here any more than you guys do, so it's Miller time. Get out of here. Feel free to come up and ask me questions, though, if you would like to